I'm going to have to see if there isn't a problem when my game runs a long time. So my screen is on, my game is running. I just sat down. My screen was asleep. So maybe it's just coming back slowly, but this guy right now is animated. And he's running slower than molasses. So I don't know why. Right? And it can't be, it's not my computer, that's for sure. In a sense where, I'm curious how much memory right now. GPU is running at 50%. There's nothing in this scene. So I don't know. Power usage very high. If I stop it and I play it again, it'll be fine, I bet. But, you know, it needs to run. It needs to run, you know, I don't know if that's because my computer was asleep or... Anyways, so, yeah. That's the issue. So what's going on, right? Let's go ahead and take a look. The boop, boop, boop. Now it's going to be in the when it's detecting, when it's going for its search or whatever it's called, up here. This is how the algorithm works. It checks the four directions. Puts those four probably in a list. I'll read for real. Puts those four in a list. And then for each one of these four, it'll go through and figure out. It's like, hey, I don't need to check here because you're already in my list. But you guys are new, so I'm going to check you guys. Now I don't need to, and then I'm going to recheck around each one of those four. I don't need to add you because I've just added you here, but I do need to add you because you're not in my list yet. And it goes around and around and around. And then for each one, it checks the distance that I'm trying to get to. And it'll move up in that direction and keep searching around. So here are the big challenges. One, I'm not using squares, I'm using hexes. And two, I will eventually want to check not just for one, but for room for three. Because is he going to move in a spot where there's only room for one? He wouldn't, because normally he would be occupying 3 squares. If I go here, there, yeah. Normally he would be occupying these 3. So I can't just check for 1 and that being a valid input, because it could be possible. He needs three around him. If there's a wall here, right, and he's occupying 3, he wouldn't be able to move closer to that wall because he's right next to it with 3. That's why that's gonna be the 2 things for the search anyway. But first thing is going to be getting this circle right. So let's read just to see there to be sure there that's what's happening board. The core of our pathfinding code will exist in the board script. Okay. If any of you have worked on pathfinding before, yeah, A star, okay. The flow of this game creates a scenario where you pick where you want to go based on the knowledge of where you can reach. Oh, interesting. So, okay, that's good, because I could make it so that I could only select something and not select where I can go. Maybe that's going to be an easier way to do it. You can reach. In other words, we won't yet know which of the tiles we could visit and move to. Okay. We will first gather a list of all the tiles within the range of the moving unit, while marking tiles in such a way as to know the path taken to reach it. Afterwards, a tile from the list is chosen, and we will already know the path and be able to simply run it. Right. Because the algorithm is a bit complex, I created the following picture to help visually walk through the game. 1, 2, 3, 4. Okay. Orange tiles. Orange. Tiles which are added to the queue for checking now. Okay. Green tiles. The tiles which are currently being analyzed. Okay. Red tiles. The tiles which are added to the queue for checking in the future. Okay. Gray tiles. The tiles which have already been processed. Plus icon indicates a tile which will be added to the queue for checking in the future. Okay. No icon indicates a tile which is skipped since it already has been visited. It's probably the no meaning, like no entry. Okay. Steps. We prime our search by indicating which tile to start from. The tile is added to a queue of tiles for checking now. This first tile has a distance of 0 and no previous tile, which indicates that it is the beginning of the path. Right. So this one here. 2. In a loop, we indicate a tile from the queue of tiles to check this round. Then we grab a reference to the tiles in each cardinal direction from the current tile and add them, right? So each cardinal direction. So in this case, we're doing 4. In my case, it's going to be 6. So for each one of them from the current tile and add them to a queue for checking in the future. Cool. Any tiles which are added have their distance set to 1 or greater than the current tile's distance. Right. The current tile is also set as their previous tile reference. So this one here, all these ones here, these 4 here, previous tile will be set to this. Right? And then this one here, all these tiles here, previous tile will be set to this. Interesting. I wonder if that might not be the problem happening here. Because if I want to go here, we're just using 1 tiles there, not 3. If I want to go here, I can go like this, or I can go like this. Right? Both of them are very, very valid. But if the algorithm is already prioritizing something in a certain direction, it might be skewing something, maybe, with previous tile. Plus icon again. Oh no, I'm here. Any tiles which are added have their distance set to 1 or greater than the current tile's distance. The current tile is also set as their previous reference. The current tile is marked as analyzed. There are no more tiles in the queue for checking now. So we will swap queues. Okay. Swapping queues. Okay. Well, it's not just a list being added, it's a separate list of queues. This is a repeat of step 2. 4. So here we do this, then we swap queues to the red. Boom. Then we do this, then we swap queues to the red. Oh no, because it has to do each one, so it's doing each one before. All this, then we swap queues to the red here again. Okay. There are additional tiles to check in the current cues, so we move on to the and the loop continues. Same basic loop, same basic loop. This is a repeat of step 3. Yeah, and this is a repeat of step 2 and 4. Okay. Now let's implement the algorithm in code. Add the following. So I think maybe what I'll do is I'll read this so that I don't get lost, and I'll go through each part of the code, and as I go through each part of the code, I'll make modifications for it to work for hexes. I'm going to make sure that that's already good, so I can validate that this page here is all good, and if there's anything left that needs modifications, like if it doesn't work after that, I'll go bug hunting. So let's go see. So it says here, now let's implement the algorithm in code. Add the following method. And that would be in board. So if I go in board, is it not open? Maybe I'm blind. Probably blind. I am blind. Okay. Let's go ahead and put that here, and let's put that there. Not true. Let's put that there. Okay. Ooh, laggy. Whoa, what's going on? Why is my computer lagging like that? What the heck? Whoa. Super laggy. That's strange, eh? Okay. Okay, so we're looking for public list tiles search. So we're looking for the search function in board. Now I do have it in board view. Search here. Okay, so tile, I set it to tile view, that's fine. Oh, this is fine. Okay. Search, we're just start function, tile view, bool, and add tile. Okay, that's good. List tile view. Return value equals new list of tile view. Good. Return added values. Start. Okay, good. Clear search. And return value will be down here. Okay, so let's see here. What am I doing here? This method will return a list of tiles starting from a specific tile which meet the certain criteria. The criteria to be met is passed along a delegate via the generic function delegate, which takes a parameter, the segment of the potential path, where you would move from and where you would move to. So that's why function tile view, tile view. Are these are spelt the same? How do you know the difference? But oh, because it's just, oh, it's not, okay, I thought it was a variable name, but no, it's the actual variable type. So from a variable type to a variable type. Okay. Oh, start will actually be defined. I'm not sure what this function tile view bool is, but so what we do here is create a list, basically an empty list, right? That's what we eventually send back to everywhere. Okay, and what we do in that list is we start by just adding the first one in that list. But then we do a clear search. Now clear search for each tile view T in tiles values. Really? Tiles values. Yeah, but that's like my main my main dictionary. Why would I want to replace my main dictionary? My main dictionary is what I use everywhere to be able to know what's on the map. It's my map. Clear search. Don't I use that to know what to check where and when? Confusing. It's not like I'm... Oh, it stays, the list stays there. I'm not clearing that list. I'm clearing it out from previous and distance values in those. Okay, everywhere. Right. That's fine. Clear search. Okay. Right. Queue tile view. Okay, so I'm making a queue. Now, a queue is different than a list. I think it could just, it's a list, but it could only be popped off from the top or something, or it's just, instead of making a list, it takes less system memory, I think. So it's kind of like a different type of tile views. So check next. So check next is going to create a new list or queue, and queue tile view check now is going to create a new one, and then good. So start distance. So the start here, the distance is 0. That's right. That's what it said here we would be doing. And then after that, everything's going to have a value of more than 1. Check now. NQ start. Interesting. So check now. NQ is probably just a function for queues, which does something, and we're going to NQ on start. I want to see what NQ does. I'm going to do F12 on this and see if it brings me something that I made custom. No, this is directly in. This is not something I made. It's definitely a function for queue. I'm going to take a look on the internet. Unity, C#. I want to see what NQ is. Just so I understand what the behavior is supposed to be. Like, does it pop it off from the top? Does it pop it off from the bottom? That kind of thing. Adds an object to the end of the queue. Okay. Okay, so I add start at the end of the queue. Okay. Okay, good. So while check now count, which would only contain start at this time, is bigger than 0, which would be because I just added start. We're going to do it on the 1, right? And then when there's more in that list, it will do it on the other ones as well. So that makes sense. Tile view T. Check now DQ. And DQ will remove it from the queue, right? I'm just going to do that. DQ is going to removes and returns the object at the beginning of the queue. Right, so you could put things on the bottom of the queue, and so NQ puts them in the bottom, and DQ takes them off from the top. I think that's what it is. Tile next, get tile. So here we just create a new one, and it says get the tile. And what the tile we're going to get is going to be the T point, the tile that we just dequeued, the point of that tile, plus the directions I less than 6, right? It might be 5. Five, 4, 3, 2, 1, 0 would be 6. But it needs to be smaller than 6. I do believe this number normally would have been 4 for the squares. If it was 3, I have 1 too many. So let's go see what normally he would have put here. Where am I? Tile view. You see here, this is where he does that. That's good. 4, yeah. So I put 6. So that should be okay. I'll go back to where I was. Okay. If next equals null, or next dot distance is smaller equal to t dot distance plus 1. Continue. If next equals null, if next equals null, why would next equal null? Oh, because the direction maybe. Right, so we're checking, we're getting a tile. Oh, wait, here, point direction plus this. Does that work? It should work. There might be a math thing here, though. There might be a math thing here. I'm going to put something. I'm feeling this is going to be a spot I need to definitely check. Because this would work for fours, but maybe not for hexagons. Adding in this way. I don't know if that's going to... Okay. If next equals null, or next dot distance is smaller equal to... Right. It has to... Next dot distance. Okay, so checking if the distance is the same. I never assign its distance. So it probably wants to check if there hasn't been an assigned distance yet, I guess. Just if that's the case, it wants to continue. I forget, wouldn't continue do return, or maybe just continue means go to the next one and not continue this here. Let me check something. For loop continue. Break and continue, yeah. Continue. The continue statement breaks one iteration in the loop. Yeah, it just leaves the loop, but it continues the loop, right? Break would just stop the whole loop. Jump out of the loop, yeah, it stops the whole loop. Okay, so here it just says, hey, we don't need to do the rest. Go to the next one, if this is true. If next equals null, yeah, okay. But, you know, if there is a tile there and it's a valid one, add tile t, right? T is the one that we just dequeued. And next. Add tile t. Oh, if add tile. I just need to think here. It's okay. Add tile right. There must be a function called add tile. But not in this script, it would seem. What the freaking heck? Can we go to F12 on that? What is that? I don't know, because I don't understand that function. So it returns a list of tile views. Board.search. Expansive unit. What is filter? For int I equals tile.count. So what I'm doing here is I'm sending this sending this list of tile views. I'm doing something to it. For each one of them in there, if the tile is equal null, so I filter if it doesn't have a unit, which is funny because I think, oh, well, it's funny because I feel like this just means it would have removed the highlight from the tile the character was on. But right now it's not doing that, so I feel like there's something going on here. Okay. Okay. Where am I now? Oh, I'm in the movement. Let's go back to the board view. Still not 100% sure what this is, though. Tile view functions to expand search. What was it called again? Function tile, add tile. How did I get to that again? Board view, add tile, F12. I don't know what this is. Maybe it'll tell me. Maybe it'll tell me here. I'm not sure. Okay, well, so far everything that I've read makes a lot of sense to me, and this is okay. This might be a problem. Here we go. What we do here is we do, if we do an add tile, and add tile, I don't know what it's supposed to return. But if this is true, then it does next.distance. Next is when it's checking, it adds the distance to it. It adds the previous tile to it. It adds the next tile in the in queue. So we're putting it in this next one, and so we were doing the check now one, and now we're adding it into the queue for the next one we're going to check. And then we're going to return value dot add. We're adding it to the return value list. So we're adding it to 2. We're adding it to the queue, and we're adding it to the amount that's going to be returned. If checknow.count equals 0, and then what we do here is when the list is, when we're done doing all this, we swap checknow to checknext. So these two here get swapped. And you'd think it would keep going. Oh, it does. Because this is still inside the while. So it'll do all of them. We'll swap it, we'll do all of them. We'll swap them, we'll do all of them. We'll swap it, we'll do all of them. And then at one point, checknow.count will be 0. Because the distance here, this is what this distance check is. Where was it? That if statement. If statement here, the distance at one point will be too far, so we'll stop adding them to the next. So when we swap them, it'll still be at 0. This will be at 0, and we'll get out of there, and then we'll return the whole list of things within the range. Right. Okay. I still don't get this thing, though. Add now. No, what was it? Add tile. Add tile. Add tile T next. T and next. It adds, like, it takes both. It takes the dequeued one, right? The one that we need to check. And a new one that we create. That we create based off of okay, and what does it want to do though? Like, I get it. It's comparing these two in some way. Maybe it's asking, should we add this new tile that I just created? Maybe that's not it there, but it needs to be checked because it was added, right? And then here what we do is we check and see gosh darn it. It returns a bull. Yeah, 12. Come on, bring me over. What? I genuinely don't know what that's doing. And I thought I had a function for this, but it's not bringing me to it. Delegate T result system in T1, in T2, out. Result T1 arc. T1 is tile view. T2 is tile view. T result is bowl. So this gives a result. Oh, is that a system? Public delegate. Oh, it's like it's not. Let me try and search that just for fun. Func C#. Maybe that's a special thing. T and result delegate. Encapsulate a method that has one parameter and returns a value of type specified by the T result. In, T, out. Type of parameter or method, or the method that is delegate in a. The following example demonstrates how to declare and use a func T result. Yeah, okay, remarks. Ugh. Stack Overflow. I like them. What is a func and what is it used for? Yes. This is a placeholder. It can be quite useful when you have code that allows a certain pattern but need not be tied to any particular functionality. For example, consider the enumerable select extension method. The pattern is for every item in a sequence, select some value from that item, e.g. a property. Okay, and create a new sequence consisting of these values. The placeholder is some selector function that actually gets the value for the sequence described above. This method takes a function T result instead of any concrete function. This allows it to be used in any context where the above. So for example, say I have a list of a person and I want just the name of every person in the list. I could do this. People.select P equals P name. Or say I want the age of the person. Parameter age, or people age. Right now, you can see how I was able to leverage the same code representing a pattern with select with two different functions. Yes. The alternative would be to write a different version of select every time you wanted to scan a sequence for different kind of values. So to achieve that same effect above, I would need presumably the code inside these two methods would look almost identical. The only difference would be, yeah, I get that. Yeah, with a delegate acting as placeholder, I free myself from having to write out the same pattern over and over in cases like this. Okay. Tile view, but it is from here. See, it's not one. And how am I writing? Add tile? I don't know, maybe I'm taking the tile view, the actual whole thing, right? Not here, it's explaining like a specific parameter or specific public variable. It's just saying, hey, the new one I just made here, right, wouldn't necessarily have anything associated to it. But it does, because I got the tile. I DQ the tile here. Then I create a brand new one. And then that brand new one is going to be the one next to the one that I just DQ'd. Okay. If next equals null, right, and then we just check that new one that I just created, make sure that it's okay, that I got something, that it exists. Good. Then what I do is if it does, I do something to it. Does it return true? And then I set its distance. I set the previous, and I add them to the lists. But what is this if it returns true? It's not comparing them. Because they're not the same. The points wouldn't be the same. It exists because we do know it exists. But is it checking if it's a tile view? It has to be because I define it here. I really have no clue. Is a predefined delegate type for a method that returns some value of t. In other words, you can use this type to reference a method that returns some value of t. So it's very flexible. You might explain it better here. This method will return a list of tiles. Yes. Starting from a specific tile which meet a certain criteria. The criteria to be met is passed along as a delegate via a generic function delegate which takes a parameter, the segment of a potential path. A segment of a potential path. That's true. Which takes parameters, which takes as parameters the segment. Okay, so it's taking in a segment, yeah, potential new direction where you would move and returns a bool indicating whether or not to allow the movement. Interesting. At minimum, the criteria will make sure that the distance to the tile is within the movement range of the unit. Yes. Other factors could include checking for blocking entities, on the tile. Note that we will need to add a using system statement at the top to use this thing. Okay. I'm curious. It's checking to allow. Will it allow? And I don't think that the tile view is particularly. It stores the previous. It stores the distance. But it doesn't store like, hey, from here you can go in all these other directions. Just saying that from T I can go to next. But can I have more than one? Because remember that example there. See, if I'm trying to go here, right? Well, I could move from here, and from here, valid direction is here. And here, and here, and here, and here, and here, but also here. But if I go here, that same tile is also a valid direction. Would that have been an issue? Yeah, that could have also been an issue with the squares. Right? If it was square, I'd be able to go from here, 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 or here, here. So, I still don't understand it very well. God, I almost died there. Okay. If I keep reading, the very first thing we need to do when starting a new search will be to clear the results. Yes. To take care of this, we will use a separate method named clear search. Yes. This method loops, so we're past the part where he explains what this is. I don't know. This, is there anything before it? No. Delegates which takes as a parameter the segment of a potential path. To allow the movement. At a minimum, the criteria will make sure that the distance to the tile is within the movement range of the unit. Okay, I guess. I mean, maybe it's like in the other stuff here, it says that it's temporary, so maybe that's just a check that will be implemented later, because the actual add tile function doesn't even exist. So maybe that's why it says, that's why we're calling it a function, where we normally don't need to do that. Just to say, hey, this is gonna be a function. These are the things we're gonna use in it. It'll probably be called add tile. And we're going to use it here right now, but really at the end of the day, nothing is being called. Because there's no function. See, what I would have done is I would have gone to go check add tile. I would have read it to know what it's doing with these, T and next, to understand what the hell's going on. Here he's telling me that it's going to add a potential direction as a possible way to go in the tile, but it's not doing that here. And I don't see where the function is that's telling me or where that's being stored in any way. So I think it's just like an empty function for future expansion, I guess. That's what this other stuff seems to be telling me, I think. Anyways, I don't know. I'm going to have to skip that one and hope for the best. If check now dot count equals 0. Yeah, okay, so we know all that. Let's keep going. Here it says to clear search. We already read that. We know it's good. Clear search. I left a comment indicating where to continue adding code. Check in the future. Clear search. That's fine. No, it's not. Why is it different? Oh, because it's right up here, actually. Okay, now let's prime the system. Yeah. We read all this. Okay, here. Okay, that's fine. Before we flesh out the while loop, add an array of points, one in each cardinal direction, as a private field to the board class. Be sure not to add it inside the while loop. Yeah, so this here, or we'll be making a lot of unnecessary extra allocations. Now, back inside the while loop. So we're going back. So here he just says, hey, look. Here are the directions. Direction points. Here. Right? What it does here is it's using this as the next check to do, which is here. Directions in the list, what index of that list, right? So index 0, index 1, index 2, index 3, index 4, index 5. If I do 5 here, is it going to complain? Yes. Yeah, so it doesn't even count 0. Kind of weird. I don't know why that one would be different, but it is. Right, and then for each one, there's a different combination. Now, is there any duplicates here? -1. 0, 1, 1, 0. 0, -1. -1, 0. -1, -1. -1, 1. I'm really wondering if there isn't something wrong with now. I've already gone through and done myself some like drawings to figure out all of them correctly. Right? I got northeast is 0, 1. Let me see. Northeast is 0, 1. East is 1, 0. 1, 0. Southeast is 0, -1. 0, -1. Southwest is -1, -1. Yes. Then west is -1, 0. Yeah. And then this last one, -1, 1, northwest. Yes. Now I'm wondering, that could have been only valid on one spot? Maybe it changes? It probably changes. It probably changes based off of where I am on the map because of the zigzag nature. I'm going to have to redraw these and see. What I need to do is I need to go into here, open this up, and redo this. So I'm going to tear this page off, or I won't tear it off. I'll just get a new page here. See, it's super important that this stuff works well because this is like the foundation of the whole thing. Once this stuff works, you never go back and touch it because it works, right? So I'm just drawing a hex here. What I'll do is I won't copy over on this page. I'm just going to grab a random one here, completely different. This one here is 14, 14, right? So I'm going to do that one. 14, 14. Northeast, east, southeast. Northeast, east, southeast. Southwest, west, northwest. Southwest, west, northwest. Good. Now what I want to do is I want to put the new points. So this one is 14, 14. I'm going to grab this point here. I'm going to take a look. This one is 13, 13. I can already tell it's not the same. So my old northeast, northeast was 0, 1. This new north, oh, am I pointing north? Shit, hold on, I might not even be pointing north because I moved my camera around. Hold on. Hold on. I'm going to restart it. Make sure I'm where I need to be. Like this. Oh, damn it. Wait, I'll move this guy under him. This right now is at the southeast location. So if I go here, this is southeast. Like this is what I want. So if I click on this one, now I know I'm in the right one. So that's northeast. Northeast is 14, 15. 14, 15. Which means it's 0, 1. Is that what I had before? Yes. East is 15, 14. Which means it's 1, 0. Is that what I had before? Yes. Southeast is 14, 13. 14, 13. That means it is 0, minus 1. And that is what I had before. So this one is looking good. This one here is 13, 13. That's good. That would be minus 1, minus 1. That's what I had before, yeah. And then this one here is 13, 14. 13, 14, which is minus 1, 0. That is what I had. And this one here is 13, 15. 13, 15. Is that right? 13, 15? 13, 15. Yeah. Which would be minus 1, 1. Is that what I had? Yes. Okay, that's cool. But I want to try something else. I'm going to do it from here now. And I'm not going to draw them because I don't need to draw. I'm just going to look real quick. So this one here is now 13, 14, 13. So this would be 1, 1. That's not what I have. If I'm going northeast, this is now 15, 14. Going to 15, 14. This one here is coming back as 1, 1. Not 0, 1. Which is a big problem. And that has to do with the nature of it being zigzagged. So I have to check if I am on a zigzag one or if I am on a non-zigzag one. And depending on if I am on a zigzag one, what direction it's going to go in for the search. It's a big, I don't even know what kind of, that check where I need to check if I'm on a zigzag or not. Like, I'm just doing that for the search right now. How crazy is it going to be for everything else, right? This is more than just a search. I mean, it's pathfinding, running around, animations. It might seriously influence the whole thing. Okay. So let me just get a sense here what's going on. I am gonna draw this one out because I need to clearly see the difference between the two. So northeast, east, southeast, southwest, west, northwest. This one is 1513. So this one is 10. And then this one here is 1512, which is 1 minus 1. This one here is 14, what is it? 1412. And that means that it's 0 minus 1. This one here is 1313. And that would be minus 1, 0. And then this one here is 1414, which is, I'm having a blank here. Yeah, okay, it's going to be 0 plus 1. Very different numbers. Very, very different numbers than what I had. Okay, thinking. And if I do this one, which is 1513, and I go up here, 1614, 1 1. Yeah, 1 1 is good. Then 1613 would be 1 0. 1 0 is good. And this one is 1612. 1612 would be 1 minus 1. That's right. That's what I had. So yeah, so all of these are using this. And all of these would be using the other one. So depending on which, and when I go up like this, it's the Y. So depending on which Y row I'm in, I need to do a different directional search. Bless me. Okay. No problem. Let me just see here. This one here is a Y of 13. This one here is a Y of 12. So if there's a remainder, if it's impair, I'm going to write that down. Impair. I use this one. And if it's a pair number, I use this one for the Y. Okay. So let's do that then. So this is for pair. I'll do directions pair. I don't even know what pair is in English. And what we'll do is we'll create a new one. I'll just copy all this. I'm not going to bother with typing all that. Right, and then what we'll do here is we're going to call it just do it in French. Empire. Okay. So, let me get those numbers out again. So, northeast is 1, 1. East is 1, 0. Oh, did that stay the same? It did stay the same. Oh, even west stays the same. It's just when you're moving up 1. Okay, whatever. 1, 0 stays the same. Excuse me. 1 minus southeast is 1 minus 1. Southwest is 0 minus 1. West is minus 1, 0. That stays the same. Northwest is 0, 1. All I'm doing really is I'm adding 1 on this side on everything that isn't east and west. Yeah, I'm not going to try and do anything too glamorous here. We'll just do 2 different directions, and then down here we'll do directions pair. Okay, and what we'll do here is we'll do the next one, we'll get the tile. But here's the thing. I need to check if it's pair or impair on the y of T point. So let me see if there's a way to do that. Can I do a math check on an int? Math check on int if pair. How do I check it? Even or odd? That's the other word. Even or odd, okay, yeah. Modulo operator to check if there's a remainder when divided by 2. People have criticized my answer above, stating that using x and 1 is faster or more efficient. I do not believe this to be the case. Okay, there's just people arguing. Now let's see here. That's really simple. So let's go ahead and we're doing it here. So what I'll do is I'll do if T point dot y modulo 2, right? And why is that telling me no? Cannot convert type into bool. Well, isn't that just returnable? Does this work? Because that'd be really easy. Let's try that. You guys are way too efficient. Is odd. Am I missing something here? Do I need to add something? Oh, does he implement it? Oh, he does a whole function. It might be useful because if I'm going to be checking the hell out of this stuff all the time, and I'll be able to read it better this way. Oh, it doesn't work for negative numbers. Well, why wouldn't this work? Because it's saying if I could just do bool, maybe? I don't know if that works though. No. Gosh darn it. If x is 2, yeah, this crazy because I mean, if just needs a bool. This doesn't even. Is there another option here? I'll just find one that works really. Let's try this. I'm not sure what n is. 1 equals 0. That works. If y even, can't spell even, right? What I'm going to do is I'm going to do pi is even. I think I'm going to rename that to the right thing. Else if point dot y is odd, right? One or the other. What is this all complaining about now? Well, it's right here. What do you mean it doesn't exist in the context? Else if? What the frick? Now it's telling me it doesn't even exist because it gets created. I'll just do this. And then I'll just take this one off like this. And I'll just set this one up here. Like this. It's still complaining? I'm assigning it here. I can't assign it in a frickin' loop? And why is that a syntax error? Oh, else if. Oh, there we go. Okay. You know, fixing this the way we just did here, that's a big fix. That could really be the reason why everything was skewed the way it was. I'm going to do even and odd. Odd point y, even point y. Even. Deers odd. So I save that. Let's try it. I mean, that's a big one. That's a big one for sure. So let's see. Let's see what it tells us. Ho ho ho, voila. Perfesa. That's perfect. That's his range. That's his range. Let's take a look here. 1, 2, 3, 4, 5. Yeah. 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Everything's perfect. 1, 2, 3, 4, 5. Nice. That's great. Perfect. Now. I should probably commit all this. Trying to think, what was I doing? I was doing the move target. Yeah. Oh yeah, this stuff here, eh? But yeah. All right, well, I'm going to save the project. I'm going to commit that. And we'll continue with our states because at this point we need to be able to select one of those tiles that have been highlighted in order for the character to move to that location.